This is known as the Cylon effect and is what we're about to start now.
So I just looked up Photocell in Sparkfun's website. I could have gone to any slew of websites we've talked about, like Adafruit or Arduino.cc, Hackster.io, Instructables. I chose to go to Sparkfun since our Sparkfun Inventors kit derived from Sparkfun, and the photocell we're going to use is obviously that product. So I just went ahead and used their search bar and typed photocell. Now, when I did that, what came up was not only the ability to purchase these things, but also some tutorials. And if we just simply focus on the Photocell Hookup Guide, we will see some pretty interesting, fun stuff. In fact, I would even favorite it. So let's just visit that now. And after lightly reading about, obviously how you should approach this is how it works. It's called a voltage divider, right? Providing a resistance of 8 to 20 kilo ohms in normal lighting conditions. Obviously works well with the Uno or Redboard. How to hook it up listed here. There's a lot of information that's really important to get a good understanding before you start and try to figure things like this out. A simple wiring schematic using a 5 volt, a 10k ohm, and the analog pin. Another schematic showing. In this case here, they have a 4.7 kilo ohm resistor. I use 10k because our Sparkfun Inventor kits only have a 330 ohm or 10k. So, erring on the cautious side, I used more ohms than necessary. It doesn't hurt it really. Here's the code that I recommend you use in this. They're using the default LED on your board, so pin 13. So if we didn't actually put LEDs on here, then 13, which is on the board. So looking at the board itself, if we could zoom in, there you could see 13, and if I were just using this code as is, that would be what would light up. But we're not going to do that. We're going to create a full 8 LED array similar. What I liked about this code also is that it talks a little bit more about how you can read the voltage, and then there's a cool way to measure resistance, and there's an equation that they're using here with an if statement. So if the light that's being measured is calculated by the voltage and resistance from it, then you're getting the analog light pin to measure that and output to the LED. So I like also that it's keeping as digital right. So in your setup, when you are measuring the output, you should be getting a full lumen good of light, as opposed to analog right, which would vary the resistance to the LED and not give you decent lumen output. So what I've done next is I visited, of course, we went to the Arduino IDE, and I and you should be opening up the previous one we done with the 8 LED pattern. So what we did before was do a full turn on of LEDs. So we had all 8 turn on one at a time. Referenced here, we use pins 2, 3, 4, 5, 6, 7, 8, 9. Right, so we had 8 LEDs, a variable holding 8 LEDs. Then we created an array called K-pin LEDs, and we referenced that K-num LEDs, which says it's 8, and then the pin arrangement. Then we used the setup here, a for loop with a loop control variable I, so that we reference the K-num LEDs in succession. So that would allow the K-pin pins LEDs referencing the initial the loop control variable of I to become output. So it's a cute little way of saying let's increment each one from index point 0 or 2, pin 2, all the way up to pin 9, which would represent then 8 LEDs. And that they'd all be considered output so that they get the full amount of voltage and grow nice and bright. Then we took this for loop where again we're measuring all of the number of LEDs, 8 again, and we're saying they're going to be high for 1 full second and then low 1 full second, and then we decrease through a decrement call here with the loop control variable I again, k num LEDs, which is 8 minus 1, and when I is greater than or equal to 0, we keep decreasing or turning off the LEDs with digital write again. So we make reference to I because it's going to hold the value that we're slowly going to decrease the value at. So what I've done is I've taken this example and the example from the Sparkfun website, and I just merged them. So here we can see that instead of calling reference to pin 13, we're going to say the same variable, k num LEDs, being equal to 8. And then we have the variable for the array, k pins LEDs, and I've now used 3, 4, 5, 6, 7, 8, 9, 10 pins, so I'm just off by a pin, but whatever. And then in our setup, similar to the code right next to it, I've basically added that into the setup so that the output for all those pins are indeed going to be output. And in the loop, I've basically added a for loop in front of the conditional if-else statement, which measures light, and if it is dark, to turn them on, else not. And then I just decrease the code so that they turn off. So it's a cool little on, off in succession whenever the light is greater than the dark threshold. And you could go through the code that I'm referencing here. Again, this is the tutorial from Sparkfun's website, and I recommend that you check out the Photocell Hookup guide. So now going back to the Arduino IDE, I'm going to upload this code now so you can see it transfer to the breadboard. So here we have it transferring over, and then it should start showing that it's reading with the RX. If I open a serial monitor in this code, you can start to see, it updates the serial monitor with how much voltage is being read and the resistance of cross. Now, the fun part, finally, if I take my thumb, there it is, and I cover, you'll see that the LEDs turn on and off in succession, similar to the Knight Rider example we did earlier. So getting reacquainted with the arrays and using the photocell, this is a pretty cool way to mash them together and get some cool effects. As you can see on the serial monitor, the voltage is dipped down to 1.41, 48, depends on how well I can hide the photocell's little self-capturing abilities. And if I release my thumb off the photocell, now you should start seeing that climb back up, and the lights are no longer actively on. Hope you enjoyed that. Again, as I cover it up, the lights turn on, turn off, light beam left to right. Hope you enjoyed. Thanks, bye.